All right. Good evening, everyone. Once more, please confirm if you can hear me. Can you hear me?
Yeah, I can hear you from my end, Gloria.
Okay.
Yes, we can hear you clear.
Thank you very much. Um. Okay. I want to apologize for not turning on my camera. Please pardon me. And then I want to welcome everyone to today's DSA section. We don't want to waste much of your time because so I just want to welcome the guest today. Is one of the NAIJA-JUG admin. Is not other person than Ebube. I would like you to react with your favorite emoji. We just have to continue. Others that join along the line will watch the record. Timothy, thank you. Timothy is the only one clapping. So Taiwo is not in the room. Joseph is not there. Balogu. Timothy, thank you. Okay, Joseph, well done. Oh, you're laughing instead of clapping. Wow. Oh, that's your emoji. Okay, that's nice. That's nice. Taiwo. Okay. All right. So thank you very much. If we can take over the floor. Thank you very much.
All right, good evening, everyone. Please react if you can hear me.
Yes, we can hear you. Good evening.
Okay, so we're going to be talking about the most essential and most basic data structure, arrays. Um, so like I want this to be a very, very interactive class. Like before I start sharing my slides, because like for you to like gain from DSA, like it has to be hands-on for you to gain anything. So like can anyone like give us like a basic explanation of what an array is? Like anyone before I start talking. Just raise your hand. All right, for the sake of time, let me just go on. So arrays are just basically a collection of items in layman's term. In a computer science term, it would be a contiguous allocated block of memory. So let me share my screen. Please confirm if you can see my screen.
Not yet.
Is it on now?
It's showing you're presenting. Yeah. So we are currently saying download. Is that where you are?
Okay. Yeah, that's where I am. That's where I am.
Okay.
Okay. Uh so let's just create a very basic. Okay. So I'm trying to just that. Okay. I'm trying to do this. DSA. Why is this not coming up? Okay, sorry about that. So basically, an array is a contiguous block of memory being allocated to store items. So usually it starts at 0. In most programming languages, I think it's only lower that the index starts at 1. The reason it's done that way is that, like, from the history of C, I don't know if anyone is familiar with the C programming language. Like, when you're doing pointer arithmetic, the array variable itself, so let's say we have an array now, and we're saying this array now is holding 1, 2, 3. This array variable now, what it's actually holding in memory is it's actually just a pointer to a particular place in memory. So what the compiler is actually saying is array is just one particular memory location. So when you now start accessing elements from the array with starting from 0, you are doing pointer arithmetic. So you are saying, okay, this memory location plus 0, that will give you the first item. So it's always pointed to the first item in the list, or in the block of memory. So now, like, that now begs the question: now, if basically what you have is just a contiguous block of memory, what I mean by contiguous is that, like, you can see from the slide, each element is next to each other. It's next to the next one. So, like, is in the same, like, basically in the same block. It's not spread out in memory. So that gives the advantage that looking up items is very, very fast. So like I said, the array variable itself is just basically a pointer to the first element in the list. So that's, in this example now, item 10. So if I wanted to look at the second item, I'll do this. I think everybody's familiar with this syntax now. The second element. In C, you can actually, is that you do this or you add it. Basically what this thing is just telling the compiler or the interpreter is, give me the item at array plus 1. So because array is actually a pointer to the first element, when you add 1 to it, it gives you the memory address of the next memory address, which stores the second element. So that's why, like right from the get-go, each programming language always starts from index 0, even though they don't usually use this implementation again. So that's the basic idea of an array. But depending on the programming language you use, it tends to mean, it means different things. So we have two main types of arrays. Static arrays. I don't want to go too much into like deep specific implementations in Java. So I just want to use a more generic one that everybody understands. So we have two main types, static arrays and dynamic arrays. So again, I think it's already clear what the difference is. In static arrays now, you have a fixed size. So if you are doing something now in Java, let me just sorry, and Java. So in Java now, if you're doing something like you have an array now, so let's just say and array plus new int of 3. So this is an example of a static array. So we're saying this is an integer array of size 3. I just didn't show me a compile time error. Sorry, I forgot to do the whole ceremony for Java. Yeah. Jesus, Java. Okay, yeah, so this basically is an example of a static array now. So you have to tell the compiler beforehand how many elements this thing is going to hold. And hence, once your language, once the code now compiles, what you are basically going to have in memory is this. You have 0, each item is set to its 0 value by default. So this is basically what you have. So the compiler, the runtime will allocate 3 contiguous blocks of memory that are close next to each other. And depending on the language you're using, some will zero them to default. Some lower languages will just retain whatever value was there. And so if you try to access them, you might get like garbage value or whatever value was there before. But most high-level languages, they tend to like zero each element to the default one. So now the problem with static arrays is that, okay, let's say you are collecting a list of, a list of shopping items now. This is an array of shopping items. So now you're collecting it dynamically from the user. So you don't know how many the user is going to pick. So you can't just say 3. So that's the problem with static arrays now. So now how do you now make this thing more flexible? And that's where dynamic arrays now come into play. In most high-level languages that most of us are now using, this thing comes in by default. In fact, if you're using things like Python and JavaScript now, what you actually have is a dynamic array of pointers. I know I just want to skip over like the basics. Folks are looking at the slides too. Everybody has the basic one now. So what you basically have is a dynamic array now. So the difference between a dynamic and a static array is that a dynamic array now can now grow in size. So you will need to specify a length. You just let's use JavaScript. Yeah. We just length shopping items equal to this. That's JavaScript. This is all. So you can keep on adding items to this thing, and it just grows like increasingly. And they still use the term array, but that's actually not what it's doing. Behind it, this is a dynamic array. So what tends to happen? We're going to implement an array from scratch in Java. So then everybody will see what's happening on the hood. What tends to happen for high-level language is that whenever it actually allocates like a basic size without you noticing. So I think each language, depending on the version you're using, they have like the default size that they use. Well, let's just say for explanation purposes, the default size the compiler is going to use is 10 or 5. So you say let shopping items equal to an array in JavaScript. The compiler is going to say, okay, shopping items behind the hood. Behind the hood is going to say shopping items is equal to a fixed array of 5 elements. I don't go into different types now. So a fixed array of 5 elements. Let's not worry about like how it's knowing which particular type it is. So 5 elements. So it now has a contiguous block of memory of 0, 0, 0, 0, 0. Each one is next to each other in memory. So as the user keeps adding items, it keeps incrementing it until it now reaches the end. It now reaches the end of the array. And the user still wants to add one more item. So what now happens? Basically what happens is that it will now have to go and reallocate a new one. Depending on the language you're using, it will now either double the size or give you like the size plus like 1.5 of the size, depending on the language and the particular implementation you use. So it's going to go somewhere else in memory. Okay, five blocks of memory is no longer enough. Let me look for 10. So it's still guessing. So it's just doubling the size each time. So it's now looking for 10 now. So now it's now going to allocate 10 blocks of memory, each one to their default values now. And meanwhile, maybe the user's items just ends here. So that's the problem. There is a trade-off. That's the problem with dynamic arrays now. You now have, it's not as efficient as, telling the compiler like, okay, I only want this particular, because now we have excess memory that we are wasting, that we're not using. And then we now have this expensive copy operation, because what it's going to do is going to go find double the size of the block of memory, some memory. Then it's now going to copy each item from here to here, from here to here, from here to here. Then replace this shopping items now points to the first element of this array. Remember, shopping items just basically point at the first array elements. So that's basically the idea of arrays. So now, very brief overview of online complexity before we start the implementation. So the main advantage of arrays is you're asking why must we? What's the advantage of storing everything next to each other in memory? The advantage is that it's very, very fast. Like you don't have to calculate where for looking up items, it's very, very fast. So let's have to look at the third item. I just have to shopping items. Which is just basically saying. Remember, shopping items is the first elements in the array, so you're just basically saying shopping items plus 2, which on our diagram will give you the third element, which in this case is it. So lookups are very, very fast in this. So it's basically an operation. If you're going on previous DSA session, I'm sure you already have an idea of what one time or one means. Basically, in the worst case scenario, as input size, it doesn't depend on the input size. So if you have like 1 million items in the array, it's going to take us roughly the same amount of time to look up any item in the array. So they are very, very fast for lookups. And then the trade-off is that for anything else apart from accessing elements by their index, it's very, very slow. Because the only information we have, we're just basically doing pointer arithmetic. This plus this pointer plus this value will give me the distance. So looking up by index, you have an overall operation. Let me move down here. So looking by index, you have an 2 of 1 operation. So very, very fast. That's good. So adding an element to the array. Let's not worry about adding it to the front or to the back. Adding an element is going to be an O of n operation. Remember, n is basically the input size. Remember, O of n always the worst case scenario. So it's O of n because worst case scenario now, the array is already full. We now to add an extra element. Remember, what the compiler is going to do is going to, under the hood, make a new array, find another block of memory, usually double the size of what you already have. Then it now starts copying each item. So imagine this was already double the size of the array. It's now double the size of the original array. It's now copying each item verbatim. Copy. So it's an O of n operation because the copying would depend on the amount of input. So if we had 1 million characters here, it would take us 1 million times the normal compute time to do this operation to copy every single item in the former list into the new one. So deleting an item is also the same thing because if you now go beyond the capacity, you also have to resize. Inserting an item, depending on where you resize, you have to resize the array. So for basically everything else, you always tend to have everything else. You always tend to have O of n operations. Do the optimizations you can take to make it O of n, but yeah, that one is beyond the scope of this. So everything else, O of n. So you might not be wondering now, why is our arrays so useful if they are only useful for looking up by index? Well, they're useful because many other data structures use arrays under the hood. Because they are very, very good at looking up items by the index, you can use them to build more complex data structures. So understanding how they work, understanding the basic idea and the basic implementations used will go a long way when you start implementing your own arrays. So let's get to the fun parts. We are now going to make an array in Java. So this one. Yeah. Sorry. To make the Java compiler happy. So let's create our new array.
Sorry, Ebube, are you still sharing your screen?
Yeah.
No, we
Did
are
you
not.
go?
No, we are not.
Oh my goodness. Oh my
Sorry.
goodness. Sorry, hold on. I think it's network.
All right, so we are not seeing your screen at all.
Yeah, just hold on. Let me reconnect again.
All right.
So okay, basically, with what I've explained now, implementation of arrays is very, very easy. So the only, not really complex, the only small complex parts would be the copying operation. We can make the array like very, very complex, but we won't do that. So, wait, hold on. See my screen now.
Yeah, we are seeing it.
Okay, sorry about that. Network has been very poor this February. I don't know, like it gets better at night sometimes. Okay, so yeah, back to what we're doing. So again, so let's think about the main information we need to hold. So basically, we're normally implementations of these things are always best done if you want to learn in lower level languages, since you'd have to build everything from scratch. But Java is also good because, like, to save time, you get access to already built data structures. So what's the name, the number one thing we want to, number one variable we want to keep as a field in our array class? Does anyone like have an idea, like, because again, we want to keep track of how many. We're first going to implement a static array. Then later on, we'll now make it dynamic by adding the resizing operation and make it automatic. So what's the number one thing we want to store in an array? Who has an idea? Like the number one piece of information we want to store in our array data structure? Yeah, you can just like, yeah. Okay, Balogun.
Okay, thank you. I think the first thing is, since we want to implement a static array now, I think the first information is to specify the number of elements that will be stored in the array.
Exactly. Thank you so much. That's it. So you can call this anything you want to, anything you want. But let's just call this counts. You can call this anything you want, but for now we just call it counts. So where counts is just basically the number of items we have. So for now we don't have anything, so our count is 0. So again, bear with me because I'm going to do something very, very hacky now. Like I said, if you really want to like learn every nitty-gritty detail, it's always best to use a very low-level language like C to implement an array.
Ebube,
Yeah.
you're
Yes.
not seeing your screen again, or did you stop sharing?
I did not do. What's going on now?
So we are not seeing it again.
Did it just happen now?
Yeah.
Just now, bro.
Yes.
Can you see me now? Can you see now?
Yes, we can see it now.
Okay, sorry about that.
You're welcome.
It just be letting me know if it happens again. Network is so poor today. This month, rather. So again, if you want to implement things, if you really want to get into every nitty-gritty detail, it's always best to use a low-level language like C. But this is NAIJA-JUG now, not NAIJA developer. So we're going to, again, we need a data structure to store the items. So we're just going to use a normal array. The reason I'm using a normal array, like, I know it's very nitty-gritty because, like, how are we building an array if we're using normal arrays? But we're going to make our own dynamic. And this one is the normal primitive variable. It depends on the Java version you use. Sometimes Java tends to convert it into a dynamic array when the need arises. So the reason why I'm saying this is that in Java, at least normal Java, we don't get access to raw pointers because ideally you would use a pointer for this, but we don't have access to pointers in Java. So I'm just going to use an array. So what's the first operation we would want to? Okay, so let's create the constructor.
Your screen is out again.
My goodness. What's going on? Sorry, bear with me, please. Oh, God. Okay, so let me just be talking while I set up. So again, what's the first like method or the first thing we want our array to be able to do? We want it to be able to add items. We want it to be able to add items into the array. Why is this? Is my screen showing now?
It's actually loading.
Oh my goodness. You know, like I'm using like both, like I'm using a router like 5G, 4G, nothing.
Maybe you just have to leave and try to join back if that will work.
Yeah, that's like the first time. That's like my audio disconnected before.
Oh.
I don't know, like how this was. I don't know what happened. Probably maybe one cable somewhere. Fiber optic cable disconnected. Because you know they usually meterize the internet. So they tend to favor like bigger companies. So they give them like access to like the faster fiber optic cables. Then to poorer countries like us, they put us on the slower ones. That's why like internet in Africa is so whack. So that's why you notice in the midnights, that's when we now start getting access to fast internet when the big people are finished using it. It's so sad.
Okay.
Is it showing now?
No, not yet.
Yeah, I disconnected. Okay, I think it's working now.
Yeah,
So
but you've not like opened any slide. It's just showing that you're presenting.
Okay, good. Hold on now.
Yes.
Let's be very, very fast with the distance. So round of 4 distance logs me out again. And so let's create the constructor very, very quickly. And length. That's Yeah, this that counts. Other than increment the count, let's say, let's just initialize the new array. Again, the reason why is in like the normal static arrays and the primitive arrays in Java is because we don't have access to raw pointers in Java. Ideally, you want to do this without like using any without using the array data structure itself. But we're going to make like a dynamic array. So that's the point of this exercise. So that's why I have to use the primitive one too as a building block. Okay, so I think everyone understands. So the first method we're going to implement is that we want our items, our array to be able to add items. So insert whatever name you want to use. So the first operation we're going to implement is the add operation. So basically, you just want this to implement to basically add an item to our array. So this one is very, very straightforward now. Yeah, it's very, very straightforward. So it's not returning anything. Add text ends item. So how do we basically we're just going to say the items array the particular counts. So if you're not familiar with Java, I'll explain the syntax later on. It's equal to item. So a breakdown of this, we're setting the current item, the count. Initially the count is 0. So we're setting that will be for the first element to the item that has been passed into the function. Then later on, we now increment it. So that's why now we use plus plus. So this one is very, very easy now. Like it's very, very easy now. So that's all. That's like the basic the same. If we're doing a static array, we are done. We're doing a static array, we are done. If the count is greater than the length, we could just return. We could just basically to a new, let's say, legal states exception. Array is 4. So if we're building a static array, we are done. Like this is just all we need to do. But again, the point of this exercise is to make the array dynamic. So this is now the only complex part in building a dynamic array, building the resize function or the copying function, whichever one you want to call it. So, okay, first of all, we're still going to use this guardrail here. But rather than throw an exception, we want to resize it. We want to resize the array and then copy. So if the items are greater, resize the array and copy. I mean, we are abstracting this away from the user. The user doesn't know. All he knows is that when he's adding an item into the array, it's going to add an item. He doesn't know that we have to do this so expensive copying or checking whether we need to copy. So again, the copying function. So what's the first thing we need to do? We have to do it. We can split it into 2 separate functions, one that resizes and one that copies it. But for the sake of time, let's just combine it together. Please forgive my let's just go resize. It's not going to take an argument. And actually, again, we're abstracting this away from user, so this has to be private. So basically, we first of all have to allocate a new array in memory. So in C, you use the malloc function, but in Java, I don't know why, like type inference doesn't tend to work in this my Java version. I don't know which one the LSP is using. So again, we're allocating a new array and we're making it the current length. That is the items. That length. Please, if anyone is not familiar with Java syntax, like feel free to like just raise your hand or call me out to explain. In Java, like if you are just referring to a field and you like it's not clashing with any parameter, you don't have to use the this keyword. Like if I was passing another variable called length, I would have to use the this keyword, but we are not, so it's automatically referring to the items, the items field right here. So again, we're allocating a new array, double the size. So the first basic part is done. Now we have a pointer to another contiguous block of memory that is larger now and can now hold more items. Now we have to basically copy. When you are solving like all these algorithms, it's always better like to just like, so now we just basically have to copy. So let's we just really have to copy. So we can let's just implement it here. So we're just basically going to loop through each item in the old array and copy it directly into the new one. So a for loop, because we already have a fixed size. You can use a while loop too, whichever one you prefer. Well, for the sake of simplicity, items dot length Abi. I'm trying to do this thing from my head, so in case I make an error. New Abi, I go to items that I. So again, we're looping through each item until with the condition that as long as I is less than the length of the array, so that will basically be the last element. So we're copying it directly. Then later on, so after copying it, if we were to just do this now, you think we are done, but we're not done. The final thing we need to do is set this this new array pointer now. We now have to set it to the items pointer. So basically, items equal to new. Items equal to new array. So that's all. So that's all we're done. Again, what this thing is, again, these two things are just basically pointers. So you're just saying make items. Remember, item is actually a pointer in memory. So you're just saying item is now equal to this new pointer allocation. So item is now pointing to the first element of the new array that you have allocated. So the thing is already there, already on the heap now. So that's all. Now you're done. So now going back to do, rather than do an exception, this last thing, we can just basically call our size function. And that is all. We have basically implemented a very basic dynamic array. So, I mean, there are so many things that I'm missing. Like we don't have like our implementation is very bare bones. So we don't have methods to check whether we have an item or not. But this is just basically the basic idea of arrays. Static, dynamic, and they're very fast to look up. So I know everybody wants to test it now. To sure that the thing will actually work. Well, hopefully it will. Let's see. Okay, let's give it an initial length of. Okay, give it a length of 3. Okay, we'll now add array dots add 1. Let's copy this. 4. Then we'll see add an item here. So it's meant to be full here, So if our implementation works correctly, yeah, what do you have here? So let me have to use the base existing function and pass in our array. So if everything works correctly, we should have 4 items in the array, even though we went past the initial length. So yeah, let me just Java compile main Java therefore Java main. I mean, sorry, I didn't input it in. Let me go back. I was trying to make this very, very clear. That's why I'm not using IntelliJ to do it. Why is not saying it's not saying the arrays class? Therefore, to add the package, the arrays. Okay. I didn't run this, and that's why it's complaining. Well, yeah, I'm going to leave the git for this time, so you can run it yourself and see that it compiles. So I think we're almost done now all the time. So let's just skip to my slides. Just memory storage, 1 access, time complexity, types of arrays, CV arrays. Yeah. Though in this ones, this other type of array, depending on like the dimensions, I think there's even for the now for those that are doing AI. But for 2D arrays now, basically you have each item store another array. So each item is basically a pointer to another array in memory. So the implementation will either be row first or column first, depending on the compiler and the particular implementation you're using under the hood. But you won't tend to see this in like 2D arrays some people consider them a separate data structure on their own matrix when you're doing graph algorithms. So it doesn't really count. So again, I'm just skipping to the slides to make sure I covered everything. Again, fixed size. So again, arrays are bad for anything apart from looking up by index. So if you're trying to find the specific elements, like you want to search if an element is there, it is bad to be of O of N because you have to basically look through each item and check whether it matches the elements application array. So again, the main idea of why arrays are so useful is that we basically use them to build almost every other single data structure out there. Hash maps to linked lists to anyone, even graph algorithms use arrays under the hood. So they're like the cements for other data structures. That's why it's very, very important you have an idea of what's happening under the hood and try to consider memory in your implementation. So conclusion, arrays are fundamental in DSA. So that was the first data structure we learned. From the next session, I will start talking about linked lists and doubly linked lists and singly linked lists and hash maps and the rest. And then you now begin to see how arrays come into play into each of these data structures, especially in things like priority queues and circular arrays, where you now have this cool hack in between them. So with this, I've come to the end of my presentation. So I will now hand over to Gloria for questions. Why I try and debug while that thing didn't compile. It's embarrassing. So again, please questions. Two. I think this was very self-explanatory. I didn't this thing compile. Okay, why not?
Thank you.
Can
anyone hear me?
Yes, I can do it.
Okay, yeah, thank you very much. Please, is there any question? You can signify by raising up your virtual hand. Okay, let's clap. See, please let's react to Ebube. That was very impactful section.
That's good. Just.
Timothy, why are you reacting with laughing emoji? Don't worry, I can see it now. All right. Is there any question so far? Thank you very much, everybody. I don't want to believe that there is no question. Balogun, are you sure there is no question?
I will not be angry because it's like it's basically a reason. Don't tell me I'm going to specify it. Do I even need to specify it
There
back
is
there?
no question. Balogun must have a question. So Balogun can take the floor.
Yeah, that's fine.
Thank you very much. Mr. Ebube, thank you for this topic.
Hi, Jesus Christ, don't tell
Sincerely
this is
speaking,
not
you really tried, and I fully understand everything you actually taught. Thank you so much. Now, my question is, if we can actually add items into the array, then we should be able to remove them also from the array. So my question is, how can we, achieve that?
That's a very lovely question. And I was going to actually ask that if you don't ask any questions because it was so because you have to ask now, we're adding items, how are we going to delete them? How are we going to remove items? So I'll just throw it back as a question because the implementation is actually much easier. Depending on if you want it to be easy. So it depends on how you want to delete items. So now we're working with the raw array now, we're implementing it ourselves. So if we're going to delete items now from the end of the array, let me go back to this markdown file. If we're going to be deleting items from the end of the array, so all we have to do is decrement the count. That's all, we're done. We just have to come here and say this counts. Are you seeing my screen? Just so I know.
Yes.
Okay, basically all we just have to do to remove an item is to just say count minus, decrement the count, that's all. Then it's just that I didn't go into I didn't add, because of time, I couldn't add many other useful methods like printing and I need both. Okay, so because you asked this now, let me just quickly open my DSA folder. I have one where I've implemented all these things already. So you are basically going to decrement the counts. So then if you have any methods now that are looking up items, they will only look up items up to that specific count. So whenever you decrement an item, it's just whatever methods you are using won't consider the items that are decremented. Let me just show it to you, so because I think until you see it, you won't fully understand. I'm sorry, if I use IntelliJ, it becomes so slow. So this is my own, I do DSA on my own. So this, so you can see we move at. You can see what this is basically doing. This is the particular method. It's decrementing the counts at the end. Checks and this, and so that's all you have to do. If you are going to, but that's you can just leave video. You don't have to. If you want to be more fancy now, if you're now deleting at the middle or at any other points, and you also have to decrement the counts, but then you now have to, depending on how complex you want your array to be, you now have to shift all the items back. So you have something like this. You have an array now of 1, 2, 3. I want everyone to get this. And all your methods now in their mind, this is where the array ends. Here. Let me just put always as a indicator. This is where the array ends here. So if if you decrement the count now, you don't see to see it as it's ending in 2 now. But if you wanted to remove, that's if you wanted to remove 3. So other methods now will only count 1 and 2. 1 and 2. They won't even see 3. So when you add a new item, because they have decremented the count, it should just replace 3 with whatever new item you added. But if you wanted to remove 2, you should decrement the count too. But then you now have to do another copy operation. That's why, like I said, for anything apart from looking up by index is an override operation. Because again, that's removing an item from the end is the best case scenario. A worst case scenario is when we want to remove the first element or an element in the middle. Because then we now have to, again, we decrement the count. We now have to copy each other item from the end to come and meet this. So we copy 4 to replace 2. Copy the items 5 to replace where 4 was. So there's always the copy operation. That's why for any other thing that is not looking up an element by the index, which does pointer arithmetic, it's always an override operation. So again, there are hacks to like, it's not like I want to do sparrows, but like when we start doing more advanced data structures, now when it comes to things like entities or secular arrays, now there's one very neat trick that you can do where you don't really have to copy items. In fact, you can keep on using a static array without needing to make it without needing to copy it into a bigger size. So the optimizations can do it, but it depends on how complex you want it to be. So I'm sorry if I made the explanation too long, but it was very important. If you didn't see someone else with that, I would have turned it out there. So yeah.
Thank you very much, Ebube. Taiwo, you were raising your hand earlier. Do you have a question? Taiwo, are you still here? Okay, all cleared. All right. Toshiko, please, before you take the floor, if you're yet to join our WhatsApp group, join us on LinkedIn, YouTube, you can check in the chat box. You'll see all our social media handles. You can follow us so you can have access to this video. It will be live on YouTube by tomorrow. And then you can still have access to the slide. Yeah. So Toshiko, you can take the floor.
Good evening, everyone. It's actually not a question, though. I just want to comment the honorable speaker, Mr. Ebube. I want to just thank him for putting up this together and for kind of putting up this wonderful presentation and on a very
So Mr. Toshiko, if you're still speaking, we can't hear you.
Yeah, your line is breaking a bit.
topic. So I'm off and
Satoshiko, if you can hear me, I think we lost you at some point. Are you there?
all right. Am I coming out?
Yes. So
Yes,
we lost
yes.
you for some while.
All right. Okay. I was actually commenting the speaker for putting up this very important topic there. Arrays is actually a very fundamental topic, and I must say I really enjoyed it. Thank you very much, and keep it going. Kudos, bro.
All right. Thank you very much, Satoshiko. Is there any other one that has a question before we call it a day?
Yes, good evening, everybody.
Oh, Timothy Baba. All right. Go ahead.
Evening, everybody. Thank you so much, Ebube, for the presentation. My question is there a relationship between this array list and set? I know that sets, it seems when you're trying to add a number, maybe there's a place you just checked if it exists, but the whole process is similar with arrays. Am I thinking in the right direction? I may be wrong. Thank you.
So, sorry, to answer your question, the thing is that like you can implement data structures in many number of ways. So it really depends on what you're trying to achieve with that particular data structures. The most common like sets use hash maps behind the hood, like use hash maps, and hash maps also use arrays behind the hood. So you could say yes, there are some sets that do use arrays in it, but hash maps are better because like in sets now, we are doing like sets, like anybody using a set expects it to have like a set expects the API to have like a basic number of operations that it can do, like lookup or adding items. So arrays will not be very, very efficient. So it really depends on like what you're trying to achieve in the array. Like if you're building a server now for a web application, and yes, you can get away with using an array. But if you're doing something embedded now, and where you really need fine memory control, you may decide to implement your own form of sets using another data structure, maybe not overlay, maybe just using raw pointers. So yes, most sets like the one that they use hash maps. Like when we get to hash maps, I think you see how they implement a guide code. So, but again, hash maps use arrays. So yes, to your question at the end of the day, many data structures use arrays from the hood, but they are fundamentally different from sets. You know, sets you only have one particular item inside it. So, but again, under the hood, they tend to use hash maps more than, in fact, sets are just basically another type of hash map. In some language itself, you don't even have sets. They expect you to just implement the in Golang now. There's no sets in Golang. It's just hash maps. There's one trick you use when you use the set. So, well, hash maps, like I said, use arrays. Most of them use arrays under the hood. There's only a few that are things to use for pointers, depending on what you're trying to achieve. So I hope that answered your question.
Yeah, you did. Thank you. Thank you so much.
All right, Satoshiko, do you still have something to say? Your hand is still up. Okay. Thank you very much for this wonderful section, Mr. Ebube. Really appreciate your time. Despite the network issues, you still conquer. Thank you very much. So we'll be having our lightning section on Tuesday. We're having our lightning talks on Tuesday, and on Saturday next week there will be no DSA. It's our monthly section, and we have a mighty person we are expecting. You've all seen the flyer. Please, if you want to know more about database, you ought to be in that section. You ought to be in that section by 8 o'clock, 8 p.m. on Saturday. Expecting to see you there. And if you love what we are doing, please reach out to your colleagues or tell a friend to join you, participate in enjoying what you're benefiting from NAIJA-JUG. So we look forward to see you in our lightning section and also in our monthly sections. We'll call it a night here. Thank you, and do have a lovely night ahead. Thank you very much. Hello.